Hey folks, here with Matt Hornak, Commercial Director of Biomerics Micro Metals. Matt, thanks for showing us some of these samples. I want to go through a few of these with me.
Awesome.
Okay, let's start with the Swiss machine laser process parts. We have a few interesting parts here, if you can kind of go through what we're looking at here.
Yeah, so with the laser Swiss, it allows us to do not only just, the laser operations with the femto, fiber cutter, but also able to do the normal Swiss machining factors of it. So this one is more of a focus on the size, and it allows us to do a flexible shaft. We have a kerf cut here, keeps it flexible for the pull wires and everything to go through it for the robotic application that this will go into. Then we have something more suitable for the single operation aspect of it, where we have the normal step down in terms of the Swiss machining, as well as the holes, the end features, all of that is laser cut as well. So it allows us to be competitive. It allows us to, continue to excel and not only be, looking towards the feasibility side of it, but looking towards the capacity as well. It allows us to run lights out. It allows us to run unmanned as well, which is really that separation between us and another competitor.
Interesting. Now we have some components that were laser processed with femto and fiber.
Yes.
Talk to us a little bit about some of these samples.
So again, a lot of these are medical applications. So a lot of it is in the steerable aspect of things. So we have a lot of, again, different applications. We have a single femto cutter that's usually for, the very precise. We can even get down to sharps as well. But a lot of that is very minimal heat effective zone, but also able to focus on materials like nitinol, materials like titanium, as well as we do stainless steel as well on that. But for the higher running things, for the multiple, so flexible shafts.
Yeah.
We want to focus on this. This is speed, all about speed and being able to be consistent cutting.
Yeah.
So what we're doing is these are all fiber. We have about 6 machines that can handle that. And then that allows us to not only cut very, very small features, but also be very precise. And then as well, on top of that, we do have in-house post operations. So we have passivation, electropolishing, we have HF, so we have pickling applications as well. And a lot of that application has to do with getting rid of the burrs and getting rid of the soot that the laser creates as well. So it creates a really nice matte finish. It creates a really nice clean cut so that, any testing, any application will be successful.
Are there any processes that can be applied to the surfaces of a laser cut hypotube to support a secondary operation, such as maybe a covering over a hypotube or a stent or something like that?
So we do have a lot of applications that we also want to bring to the table as well. It's, we can do cutting, that's great and all, but we also have other applications, whether that's welding or whether that's marking and ablation. So I know that there's a lot of people where the glue, so the ability for an overmold or an extrusion to be able to adhere to the tube is key. A lot of people come to us and say, hey, can you guys bead blast this? And every single time we're gonna offer that ablation step as well, because not only can we match the bead blast finish, but reusables are gone. We can do it a lot quicker. And then we have tooling in-house that we make to allow us to adapt it and keep up with any capacity that might be out there.
Interesting. Matt, as you were giving me the plant tour, I just see racks and racks of inventory of hypotubes.
Yeah.
So I wanted to ask, what is the size range that you work with along with the materials as well?
Exactly. So what we mentioned before, we have obviously the laser Swiss. Those are for, the higher running production. We have, as you'll see here, we have a component behind us that, we're doing upwards of 15,000 to 20,000 a week. We have bar feeders to allow us to, again, run lights out, keep up with production, running 3 shifts here. But not only that, but we also are able to keep a bigger size, bigger wall thickness. So what we're able to get up to is right around 3/4 of an inch in diameter. And then that's mostly with the laser Swiss. With the laser cutters, we are able to get down to a much smaller size. So we can do things down towards the 18 thou in diameter range, and even a wall thickness of around 2,000. So we have a really good range, but also, you know, again, scalability is what we want to do. So we want to be there at the very beginning with you. And what we'll do is we'll focus more on the laser cutting side if we're able to, with the MPI work, quick iteration, feedback, and then quick changes. The other thing we want to do is, you know, continue to scale, continue to work with you to make a component that is manufacturable. That's a really big key for us. We want you to be successful. And it is a partnership at the end of the day that we want to be there for. Yeah. And we want to be there through the whole life cycle as well.
Yeah, that was a couple themes that I've heard today, is design for manufacturability and also design for automation.
Exactly. Yeah, so similar to, you know, laser cutters have a, you know, unlimited feed, you know, ability, where it's, you know, something, again, like the ability to load bars in and continue to run for 4 hours with being unattended. That goes hand in hand with again, our welding, our marking, and the ability to incorporate all those aspects. And, you know, whether it's robotic feeding or whether it's automated in-process inspection, dimensionals,
yeah.
that's that next tier that we're trying to get into and continue to grow and expand in.